Okay, so we're going to go through graphing rational functions now, where it's not specifically a reciprocal, it's just some sort of rational function. I've got some key points that I'm interested in. The x-intercepts, of course, if there are any. The y-intercept, if there is one. Knowing that it's a function, there can only be one. Vertical asymptotes, if they exist. Usually they will if I'm looking at a rational function. And well, always they will, I guess, if I'm looking at a true rational function. And horizontal asymptotes, again, assuming they exist, and usually they will. So if I look at my original question, one of the keys here will be to have this in a form that I can work with. So I'm going to actually factor here to start. I'm interested in knowing things like when the denominator is 0, as well as where sort of those key points are. To figure out where the denominator is 0, my best bet will be to factor that part. So I could have waited a little bit to do that, I suppose, but I'm doing it now anyways. X squared minus 6x minus 7, I need two numbers that multiply to negative 7 and add to negative 6. And so that will help me eventually when I get to the vertical asymptote specifically. So x-intercept, we'll start there. We're looking for what forces my expression to be y equals 0. Again, I suppose I should go back to keeping it the way we've been looking at them. So x-intercept, y is 0. For f at x to be 0, that means that the top, the numerator, has to be 0. So the only way that's going to happen is when the numerator is 0, the denominator doesn't come into play at all with a division that gives me an answer of 0. Something 0 divided by anything gives me 0. Anything divided by 0, of course, is a problem. And in case you need to see a couple of steps here, so the x-intercept is at 4.5. So there's my x-intercept. Let's keep that out of the way for now. My y-intercept, the y-intercept occurs when x is 0. And so when x is 0, if I look at my expression, I get 2 times 0 minus 9 over, now I'm actually looking at the original here, 0 squared minus 6 times 0 minus 7. Could maybe pick slightly nicer numbers, but 9/7 is my y-intercept. And so just kind of counting up here, 1, 2, 9/7 is a little bit above that. Just trying to get a nice feel for where it is. It's between 1 and 2, closer to 1 than to 2. Again, it's a sketch, and so that's good enough. Now, super important, the vertical asymptote, or asymptotes in this case, occur when the denominator is 0. For the denominator to be 0, then these two values must multiply to 0. And so that occurs when x is 7 or when x is negative 1. And so if I just continue out here, 6 and 7, negative 1, I'll have asymptotes at those two spots. And not exactly what I wanted. So those are my two vertical asymptotes. This one is at x equals -1, and this one is at x equals 7. So that's the majority of my graph. Obviously, without knowing the horizontal asymptote now, I don't have much, and so that's going to be pretty important. What I want to recognize too, though, is around the vertical asymptotes, there's only two possibilities. On each side, my graph is either going to go up the face of a vertical asymptote or down the face of it. Same is true on the opposite side. And so knowing that, I'll be able to, in a few minutes at least, figure out pretty quickly what's going on as far as am I going up or going down. If the values are going to be positive values that I'm getting, then they'll be going up. If they're going to be negative values, they'll be going down. So just sort of keeping that in mind as we move forward. Horizontal asymptotes. So this example is showing something very specific. It's showing an example where my numerator has a power which is less than the power of the denominator. Okay? So the degree of the numerator is greater than the degree of the denominator. Sorry, it's less than. I said that backwards. What happens then, and again, this is just a sort of a logic sort of, keep that up, a logic sort of exercise. When I start putting very big numbers in, whether they're negative or positive, if we look at an example like just, what happens if I test a number like 10,000? My numerator is this. My denominator is this. Sorry for writing this over top of the existing graph. I'll pull it over here. So my numerator goes toward, is just a little bit over, a little bit under 20,000. My numerator is just over just under 20,000. My denominator, this value right here, is 4 zeros, 4 zeros. So we're looking at what? 100 million minus 60,000 minus 7. And so the top is at about 20,000. The bottom is at about 100 million. If I put bigger numbers in, so add a couple of zeros on the top here, I end up with a couple more zeros here, which is somewhere in the neighborhood of, my numerator goes to about 2 million. Add a couple more zeros in here, I end up with 4 more zeros in here, and my denominator, getting them backwards here, is in the neighborhood of, what is that? 1 trillion. So you can see, or hopefully you can see, and certainly you could test it some more, a numerator is getting bigger, but at a much slower rate than is the denominator. And of course the reason for that is the x squared term. The other two terms in my denominator are really insignificant compared to the x squared. This number is now 1 billion. This number with 2 more zeros is 6 million. So I'm taking 6 million off of 1 trillion. Sorry, so 1 billion a minute ago. I'm taking 6 million off of 1 trillion. And that's insignificant. So I'm going to back this up a little bit, get rid of some of this mess. So essentially, without having to necessarily write that out, I can look at my expression and say, on top, the significant term is the 2x. In the denominator, the significant term is the x squared. As the numbers get really big, the other numbers, the 9 specifically, is absolutely irrelevant. And then the 6x and the minus 7 also become irrelevant. Well, 2x over x squared is essentially the same thing as 2 over x for our purposes. And so when I look at 2 over x and I think about the numbers I'm putting in as being extremely large, either positive or negative, 1 billion, 1 trillion, or negative 1 trillion, this term ends up getting really close to 0. If you divide 2 by 1 trillion, you get 0.00000, whatever it happens to be. If you divide 2 by negative 1 trillion, you get negative 0.00000, whatever it happens to be. And so all of that to just kind of say, whenever we have whenever we have a numerator that has a power less than the power of the denominator, or again, the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is always 0. Or I should say, is the line y equals 0. Now again, the understanding behind it is this sort of thought process up here, that the big numbers on top are nowhere near as big as the big numbers on the bottom, and so when we divide a number by a much bigger number, we get answers that are close to 0. If you choose to just kind of memorize that almost, that anytime I have a situation where my numerator has a smaller degree than my denominator does, there's going to be a tendency for that to go towards 0, and I'm going to have that's not what I wanted. I'm going to have a horizontal asymptote at 0. I want to turn that red so we can see it better. Actually, I'll even take out the, that's me. Okay, so now I have a horizontal asymptote at that 0. Now, knowing that, I'm just going to pause for a second here. Sorry about that. So knowing that now will allow me to finish up the question. So basically what I've got, and it's kind of an interesting one, I didn't know this was going to happen, but I've got a value here, and a value here that need to be joined together. Right away I see that I seem to have a confusing situation with, I'm saying there's a horizontal asymptote on the x-axis, and I'm also saying that this point is on the x-axis. What you want to recognize, and you won't run into these today, but you'll run into them at some point, is that the horizontal asymptote is what happens as we go out, as we get those really big values. And so, unlike a vertical asymptote where no value will ever cross that line, the horizontal asymptote actually is crossable. It's just not crossable on its extremes or on its ends. And so it looks to me like what's going to happen is this. To verify, I probably should use a couple of values just to sort of make sure. And since my vertical asymptote here is at -1, I can test values that are a little bit smaller than -1 and a little bit bigger than -1 and just see what happens. So if I go to, if I put in a number like, sorry, I stepped on the cord and unplugged myself. If I put in a value like negative 0.5, what I'm interested in is, am I getting positive numbers or not? Negative 0.5, I get 2 times negative 0.5 minus 9. On top, that will be a negative value. On the bottom, I have negative 0.5 minus 7, negative 0.5 plus 1. This is a negative value over here. This is a positive value over here. So the denominator is negative. I end up with a negative divided by a negative, which means I should be getting positive numbers. So I feel pretty good about the idea that this is going to go up this way. Similarly, I can test values on the other side of negative 1. Numbers like negative 1.1, negative 1.001 are often said to be the ones you want to look at. But really, if I try something like negative 2, it's going to tell me what I need to know. So if I just test negative 2 specifically here, and again, I'm interested in, am I getting positive values or negative values? Meaning, should I be below, should I be in the negative numbers going downwards towards the vertical asymptote, or should I be going in the positives going up? The top, again, is going to be a negative value. The bottom, this is negative, and so negative, 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 these two multiply to positive, and I'm going to have this over here. The rest of it I can just kind of piece together because I know I'm going to be approaching that y-intercept, or sorry, that horizontal asymptote and not crossing it. Over here, I have to assume what's going to happen is I'm coming down towards the 7, but again, just sort of test a value like the number 6 and see what happens. Hopefully it'll be a negative number, in which case I know that subsequent numbers will also be negative. That's going to be positive on top. That's going to be negative. That's going to be positive. So yes, I'm going to get negative numbers here. And I'll head down this way. I don't have a lot of room on the other side. But again, just kind of testing a number like 8. I get a positive number on top. I get a positive value there. I get a positive value here, which means that on this edge, I'll be doing this, and then on this part, I'll be heading out that way. Okay. So, a little bit trickier one than any you should run into, I think, for the next day or so at least. But the process will always be the same. Now, again, a lot of steps, I suppose, but none of them are too terribly advanced. Find the x-intercepts if they exist. Find the y-intercepts if they exist. Vertical asymptotes, basically figure out where the denominator will be 0. And then our first horizontal asymptote happens when the degree of the numerator is less than the degree of the denominator. And they will always be horizontal asymptotes of 0 if that occurs. I'm going to very, very quickly, actually I'm going to stop it there and put up one more quickly afterwards.